Okay, so here's some here's sort of some a range here of questions from when you're working with patterns or graphing equations, linear equations. The word linear just means straight line. So over here we have a line through our Cartesian graph, our coordinate graph. We have different quadrants, quadrant 1, 2, 3, and 4. So you can see these are all positive numbers. One thing I didn't actually do was label the actual y and x axes, which is something we should always do um, because that's important. Okay, so what you've got when you've got the different quadrants like this, coordinates graphs like this, is y's up and down. So negatives are down on the vertical axis, and on the positive on the x-axis it's to the right it's positive, and to the left it's negative. So, and the different quadrants, so positive y and positive x is quadrant 1, positive y and negative x is quadrant 2, negative and negative is quadrant 3, and obviously positive x and negative y is quadrant 4. So they're the different quadrants. You want to be able to plot coordinate points for achieved. So if we'll be doing that on the graph. So, but I'll just show you how that quickly how that's done. If I am going across the x-axis, that is following this pattern here, x and y. The x-axis in the coordinates is first, and then comma, and then the y is the second. So, for example, I'll just copy that and duplicate it, so you can sort of see if I change this to uh, 3, and 4, like that. The first one is x going across the x, and the second one is y. So it could be negative or positive on both of them. So we're going to plot this coordinates here, x and y, and this would be achieved type stuff. So I'm going to shrink it down a little bit so I can put it on a graph, and I'm going to use a marker circle here to plot it. So 3 across the x-axis. So here's the origin point, 0, 0 coordinates. I go across 3 and up 4, and that would be awesome. Cross 3 and up 4 would be those coordinates. And you would so you draw the dot, and then you would write the coordinates x and y in brackets like that next to the dot. So that's plotting points. That's achieved level, plotting points on a coordinate graph. Coordinates. If I'm looking at this intersection point of this line as it goes through the y-axis, the up thing, I can see the x-axis is going across is at 0, and the y would be at 4. So it would be 0, 4 if I was plotting it like this. Okay, so that's how that works for coordinates for achieved, for plotting. And we'll do that, and we'll plot a few points later. Okay, so let's have a look at some more achieved, and I'll head towards excellence. So sometimes you'll be given a number pattern. So I'll work with number patterns, and we'll plot the number patterns later. So I might be given a pattern of either objects like matchsticks or anything. It can be any sort of objects, items, or it could be a number pattern like this. It doesn't really matter. This number pattern here actually just matches this number pattern here. So if you are given pictures like this, you represent them as numbers in a pattern. So I'll turn that into a 1, 3, 5, and 7. So if they do give you pictures, just turn it into a number pattern. So that's one step. If I give you a number pattern, you don't have to obviously count everything and turn them into numbers. But the first step is, if it is pictures, you just turn it into a number pattern, and then from there we would work out our number pattern. Okay, so to do this, I will create a X and Y. So I'm going to do this with pen just for speed. So I'm going to write, use a little grid. Now this X here, this graph thing here, X there, is just a horizontal version of this X and Y that I've got down here. It doesn't really matter which way around you do it, this way, which is vertical, or horizontal, okay? It doesn't really matter, but I'm going to show you both ways so you can sort of see how they work. And I'm just going to label it X and Y. You could label it different letters. They're just letters. Sometimes N or T. In fact, that is actually a good way of doing it. T for the term. Sometimes N for the number. Yeah, I'll do that. N for the number and T for the term. But it's the same as labeling X and Y, and you'll see. But I'll just show you so you understand. Sometimes you see it in this form, T and N. Okay. Okay. So we'll start at 1, the first number, and then we'll go 2 and 3, and I'll show you what it corresponds to in a second. Now, remember, it could be, this would be, I could have labeled them any number, but I'm using N for the number. This one here is number 1. This flame here is number 1. Okay. And it is 1 down there, which is a little bit, yeah, so that really doesn't help too much with that. That's actually 1. This one here is actually number 2. So I'll just do that. Number 2. That there, number 2 across in the sequence is actually 3. Number 1 in the sequence is 1. Number 3 in the sequence is this one here, which is 5. And number 4 in the sequence is this one here. The fourth one along is 7. Now, they might, for achieved, ask you to find the next 2 terms. So, say, what is the next 2 numbers in the number pattern? So, predict what number 5 is going to be based on this pattern and what number 6 term was. A lot of the time you're trying to find what is the nth term. In other words, what's any number. Nth term means n is these numbers. Nth term could be, you want to find the 100th term, and you're not going to go right along and find the pattern one by one sequentially. You have to work out a rule to be able to find the nth term, and that's where it heads towards excellence, okay? When you find the actual equation which plots this. Okay, the equation will look something like this down here, y equals 2x plus 1, something like that. And that is what you're trying to find to get excellence, is look at the number pattern and not just guess what the next 2 numbers are, which is like achieved. And I can guess that it seems to be going up by, let's go, from there to there, it is going up by 2. From that term to that term is going up by 2. So this is the steps you'll take. First step, when you're doing this, is turn it into a number pattern. Third step is write a graph like this and put the numbers as the terms along. Third step is this one, what I'm doing now, and that is look at the actual difference between each term, what they're going up by or down by. They can be going down negatively or up, and the number might not be constant. If it's not constant, that means it is not linear, which means it will not make a straight line if you plot it. But you are at year 10, you're only plotting linear, okay? So when I see this 2, 2, 2 pattern, I know that's going to be a linear line equation. Okay, so it's going up by 2, so I know the next term, if I keep following that pattern, it's going to be 9 and then 11. So I've got achieved now because I've noticed it's going up by 2. I've guessed the next 2 terms, so that's achieved stuff. Okay, so the sequence is pretty easy. Either you're given a sequence of numbers and you work out what is the pattern between the numbers by counting the difference between each one, or you're given graphics which you have to turn into a number sequence. But putting it in a N and T sort of graph like this is going to help us find the excellence. Now, I'll show you how this works. Alright, so let's see if we can work out this number pattern. Now, there's a few ways we can do it. We start with y. We'll just say y equals something. Y equals something. That's how we start it. I'm going to look at one easy way is to go, well, why don't we go back one, which would be going back one, which would be minus 2, wouldn't it? To sort of look at what that number is, and that would be the zero number. Now, if I do that, if I go back one, that'll go 0 and then negative 1, won't it? So that would be that at 0, that would be negative 1. That instead of 1, it would be negative 1. If I do that, I can sort of guess what the some of the stuff that I need to get by going back one. This number here, the plus 2, is going to tell me this. It's going to give me this part here. So in an equation, you always have this y. In a linear equation, you always have a y equals something question mark x, and you might have on the end a constant plus or minus on the end something. You might have nothing. It could be 0. So you're trying to find out what is in front of the x. Is it a 1? Is it a 2? Is it a negative number? Is it a third, a fraction? And at the end, you're trying to find out, is there a plus or minus some number at the end? So you're trying to find, like, as I was saying before, something like this. 2x plus 1. You're trying to find what is in front of the x and is there anything on the end. So this is what you're trying to discover. Now, the part in front of the x there, already have discovered it's a 2, and that was because it's going up by 2, positive 2 each time it goes through the pattern. So I discovered the x term part. But now I'm trying to work out what goes after. Is there anything? And to do that, I just can plug in some numbers. I can go 2 times whatever x is, and that x there is actually whatever n is. So let's go to the first term and go, if 2 times 1, so if that x is 1, what does that give me? Does it give me the number underneath? So let's just plug in and see if we check it. 2 times 1 and see what answer we get, and if we see if it gets this number here. Okay, we're trying to use this number here to see if we can get this number by multiplying it by 2. So 2 times 1 gives me 2. It doesn't give me 1. So to give me 1, I have to what? I have to minus 1 to get 1. All right, so that's interesting. That there would actually solve the equation, the minus 1 on the end. So that means the end part I've worked out, it's minus 1. But did you see that if I went from here backwards to 0, it also told me what that end number, that bit there was going to be? So there is actually multiple ways to do this. One is substitute the 1 for x over here and just multiply it out and then work out by adding or subtracting to try and get that number. So I'll show you what I mean. If I substitute by 2 times, so go 2 times 2, times 2, it gives me 4, okay? Oh, sorry, 4. 4. So I look down here and I go, okay, 2, if n is 2, and my going between is 2 times 2 gives me 4, but there's a 3, so I have to go minus 1. So again, I get back to minus 1. So I've worked out my equation, which is excellence level, by either going backwards to the 0 turn and finding out what that number will be, and that tells me what the number on the end is, or substituting one of these n numbers in and multiplying it by the difference between each number. I could have gone 2 times 4 and then find out how to get to this number here. Any of these numbers along the top I could have put, instead of x, I could have used one of these numbers. It might have been better for me, instead of using x, for you to understand that I could have used n, and then you'll realize maybe what I'm talking about. The n number is this number sequence here. So by replacing n with one of these numbers, 1, 2, 3, or 4, I can go 2 times whatever n is, and then see if I can get the number underneath it by either adding or subtracting to get there. Okay, so anyway, that's one way of doing it. Okay, that's how you can get excellence. Let's that's getting a number pattern, finding the difference between the numbers, and that tells you what goes in front of the x, and then either working backwards to 0 to find out what that number is on the bottom, and that tells you what's on the end, or substituting in one of the values and then working out how to get the number underneath. Okay, either one of them will work. I'm not 100% sure if I did a good job. Okay, anyway, another thing, a skill that you might need to do is you might get a formula like this and they ask you to graph it. So they say graph this equation. So instead of working out the equation from a number sequence, which is, remember, excellence level, they might say just graph, I want you to graph this equation. And this would be like achieved, okay? So when you do this, the best way to do it is get some values, just make some values, going from 0, having 0 in the middle, maybe -2. You can have as many as you want. You can have -3, -4, -5, whatever. But I'm just going to do a few values and make sure 0 is one of them. It's pretty, important you have 0 there. But you can make this as long as you can. Sometimes you have to be like -10 or something for it to be able to graph it, okay? But based on what the number is. If this is like -20 on the end or something, then you've got to adjust these numbers so you can graph it. But I'm using a really simple equation. Okay, so I just pick some random numbers and I like to have 0 in the middle, and then go backwards and forwards and see if I can get some points. Now what I'm going to do is I'm going to use the 2 and I'm going to multiply it by one of these numbers in the x column. So this 2 here, I'll just show you what I'm going to do. I'm going to go 2 and then substitute where x is for one of these numbers here, okay? One of these x's. And the best one to do to start with is put, instead of having 2 times x, have 2 times 0. So substitute that in, and then add 1 on the end to whatever that is. So 2 times 0 is 0, plus 1 equals 1. So the corresponding number when I'm working this out is, for the y, is 1. Notice what we're doing over here with x and y. All we've done is now is made an x and y coordinate pair from my column here. My column of numbers I chose for x, substituted in the value, and now it gives me a y. So now I've made an x and y pair, and this one just happens to be 0 and 0 across the axes, and 1 on the graph. So if I wanted to plot this, I could go over to my graph and go 0 along the axis and 1 up y. So that point would be around there. Okay, so I'll just write the coordinates next to it, 0 and 1, so you understand what I'm plotting. 1. Awesome. Okay, so, alright, so I've got 1 point. You need 3, basically, to plot a line. Okay, now I can go, okay, so I put 0 in, and I worked out the coordinates for this. 1 point for this graph. Now, what happens if I put plus 1 in? Okay, or maybe 2. Let's do 2. We'll do this one. 2. So I'll go, I'm using this part here, okay? 2 times x. So 2 times 2. Where did I get this 2 from? This 2 here is, this column here is x's. That's the 2 I'm using, okay? Using that 2 for this 2 here, which was, as you see up here, x. Okay, was x. But instead of putting x there, I've put 2 in, and then what I'm going to do is add 1 on to the end. So 2 times 2 is 4, plus 1 is 5. So my y point, if I'm plotting this, is 2 and y. Okay, so it would look, the coordinate is 2 and 5. Awesome, I've got 2 points now. I only need 3 to plot my line. So 2 across and 5 up. Okay, 2 across and 5 up. Where are we? Here's the 2, and 5 is there. So, oops, I should have done it in red. 2 and 5 is there. Okay, and now I've got a point. Which, remember, you have to be able to plot coordinates, otherwise you can't do this. Okay, so I've got 2, and remember I need 3. Now a nice one maybe is a negative 1, or another positive 1, and then I can get a ruler and I can draw my line. Okay, should we chuck in a negative? Let's try doing maybe this one, the negative 2. Okay, so I'll chuck in that. So that will be 2, and instead of x, I'm putting negative 2 now, plus 1. The plus 1 is that number there. Okay, so now I work it out, and it's 2. Remember, this is equal to y. So that's why it goes in the y column. Because we're trying to find out what is the y value if I put 2 times negative 2 plus 1. What does y equal? And that's why I put it in this table. So 2 times the negative 2 is negative 4, plus 1 is negative 3. So there it is, negative 3. So now I've got my pair. I can go like this, negative 2 and comma negative 3. Negative 2 across, negative 2 on the x and negative 3 on the y. So let's go across, negative 2 on the x and negative 3 on the y. Brings me down to there. And I should label it -2 and -3. Oh man. Okay, now you want to, once you've done that, you want to get a ruler and try to draw a straight line through your points. And you want to keep it so it goes right through and does a nice accurate line. And it's got to somehow pass through all the points. See how it's passing through the points nicely? Awesome. And you can then label that line by saying that is y equals 2x plus 1. So now we have basically plotted a line. We got an equation. We made a table. We gave it some x values that we came up with ourselves. I used 1 to -3 and then to +3. I substituted in x for the x values to work out what the y values would be, and then I've made coordinates out of them, and I've plotted the successfully plotted the x equals 2x plus 1. Now that is that is one of the skills. Okay, so that's it there. Okay, now I'm going to teach you another sort of excellence one more thing you might be asked is, you might be asked this, you might be asked this question, find the y-intercept. Okay, of that line that we just plotted. Now the y-intercept is where the line crosses the y-axis. So if I look at that line, I can see that my y-intercept is where it touches it's supposed to be there, touches the y-axis, goes through, and it goes through at 0, because it's the y-intercept is always at 0 on the y-axis, right in the junction, and then it's going to be either positive number or it's going to be a negative number. In this case, the y-intercept is 0 and 1. This is where that line touches intercepts the y-axis, touches it right at that junction right there at 0 and 1. That is the y-intercept. And so if you're asked to find the y-intercept, it is at 0 and 0 across. It's always 0 for the y-intercept for x, but it's where it touches on the y-axis is that's the y-intercept. The y-intercept, if you look at it, is the last number without the x. That number without the x is actually the y-intercept, because you can see it touches the line at +1. So looking at the formula, you notice that if there's a number without an x next to it, it'll be the y-intercept. So let's have a look at this line that's already on there. This other one. Let's have a look at this line. This line. Okay. That one. And let's have a look at what the y-intercept will be. So that means the number on the end. Where is it crossing? It's crossing at 0 and at 4 on the y-axis. So that means when I'm writing this equation, if I'm trying to work it out, I will go, there's a +4 y-intercept on the end. I've now done half of the equation by finding the y-intercept just by looking at where it touches the y-axis. So I've got half. See, I need the now I need the x part. What is the x part? Is it a fraction? Is it a whole number? Is it a negative number? What is it? So since I've got the plus on the end, I know that it touches there. I've got that end part. Okay. Now to work out the x part, that is actually called the gradient. Okay. This end part's called the y-intercept, but the part with the x is called the gradient. Now the gradient means this. It's also called the slope, and that means the slope of the line. So when we're looking at how steep a line is, the higher the gradient, the steeper the line. Okay, so this 2x is, if it's really a big number, it's a very steep line. If it's negative, it'll go downwards. If it's negative number there, it'll go downwards. Okay, so the gradient, this is the x part I'm trying to work out, this 2x part. I need to find the x part on this line here, how steep it is. Just by looking at it, obviously it's going to be less than, it's not going to be as steep as that one. So anyway, let's work it out. Let's just work it out. What could it be? Okay, what could the gradient be? And I'm going to have a guess. We're going to work it out. Now, to do this, you can easily do this by starting at the y-intercept, and you're trying to look at where the line, I'm going to delete that one for a second because it's confusing, very confusing. What I want to do is I want to start at the x, and I want to go rise over run. So this is what the gradient is, rise over run, okay? So I want to go, rise means x means the x value, and run means the, rise means the y value. So we could just call that the x, and that's the run, and the y is the y value. So okay, so let's have a look at how we work out the gradient or the slope, the rise over run. We start it there, the y-intercept, and we're going to go, we're looking for where the line crosses over, this line here crosses over one of these straight lines. So it's easier with grid paper in reality to see this, but I'm going to try and see if it I can do it. Wish I could colour these lines better. Okay, I really need grid paper, to be totally honest. It's way easier with grid paper. Way easier. But we'll do what we can, because I'm using this online software is actually really hard to do tutorials on, because you don't have you have to draw everything, okay? So what I'm looking for is the intersection of where the line, this line that we're plotting, crosses over at a perfect point that touches on a cross section of the y and x. Okay, and I've found one. Neat. There it is. There's one. Perfect. And I'll copy that because we might be able to find another one. Let's do one there. And copy another one. As I said, grid paper is way easier. Way easier. Is there one there? Is there one there? No. Okay, let's have a look at this. Is what I'm trying to work out. I'm trying to work out, because as I said, without grid paper you can't really see it, and I wish I could find a better software for this, but we're nearly there. One more, and then it'll be worth the wait. Okay, so here's my hashed out grid paper to try and work, show you how to do this. It's not very precise because it's not grid paper, but anyway, I've done my best. Okay, so let's explain this as best I can. This video is getting longer and longer. Okay, so I started my y-intercept, and I want to go rise over run. Rise means go up, and run means go across. So I want to go up. So if I go up 1, rise, I'm there. Now I want to go across 1, and am I touching that line? Is that line going through this? Is that line going through that junction? No. So going up 1 and across 1, this line that I'm trying to map doesn't touch it. If I go up 2, so 1, 2, and then I go across 1, the line's nowhere near it, and if I go across 2, the line is nowhere near the junction. So if I go up 3, going up 3, the rise, and go across 1, 2, 3, it doesn't match either. But if I go up 4 for my rise, and then across 1, 2, 3, it is there. There's a junction. The line meets a junction, which means this is 1, 2, 3 across, and 1, 2, 4 up. I've now worked out my rise over run, my gradient. The slope of my line is rise over run. So what is it? Rise is 4, and my run is 3. And that is my x value, 4 over 3 x. Yay, I just worked out the formula, by starting at the y-intercept, going up and across until I found a place where the line hits. I'm looking for the very first spot where it hits, if I can. Otherwise, I have to simplify that down by simplifying it down. But because I've gone up and across until I got to one where it's the very first one I come across, because later on you'll find another one as well. But then you would have to simplify it down to 4 over 3 anyway. So basically, you could find one. I can tell you where it'll be. It'll be at 8 and 6. Notice this one here is just half that. So this here is a gradient, but it's not the most simple. It's not 4 over 3. It's not the most simplified gradient. So anyway, that is excellence level. Being able to find the formula for a line that's already on a graph. That is excellence level. Whew, took a long time. So what are the things to remember? Finding the y-intercept in a formula. If this is a formula, an equation you're given a formula like this, 1/3 x minus 2, like that. I know that this number here has got an x, and this number here has got no x. So this here is my y-intercept. Yay! That's my y-intercept. So that means I know that the line, if I was plotting it, I know that the line has to pass through that point there, negative 2, on the y-axis. Cool. So that's the first point. It tells me, this here tells me, rise over run, rise, go up 1 and across 3. So from this point on the graph, at my y-intercept, if I go up 1 and across 3, if I go up 1 and then across 3, 1, 2, 3, I've now actually plotted my second point just by using the gradient. And if I want to do another point, I could go up 1 and go across 1, 2, 3. I now have got a third point. Now I can draw my line with a ruler, of course, and I know that this line will be this here, okay? Because the gradient is where it touches the y-axis, and this is going up 1 and across 3. And I can do it like that. So there's multiple ways. I've showed you how to use a table and then substitute values to get x points to draw a line from an equation. Or you can actually use the rise over run. This here, this formula would be easy to plot without even doing a table. This 2x plus 1 is easy to plot because I would just go, okay, cool. That there is the gradient, is the y-intercept, so it's plus 1. Okay, I know it's plus 1. That there is this. It's a 2, so you go, well, that's easy. Rise over 1, 1/3. Well, what's this one? Well, if there's only one number, it's rise over run would be 2 over 1. That means you have to go up 2 and across 1. So if we go back to our map, I'll use a different colour, and I plot the plus 1, there, plus 1. If I go up 2, 1, 2, and then across 1, here's my second point. And if I go a -1, let's go backwards, and then down 2, there's another point. And if I go from this other point I did here, up 2, 1, 2, and across 1, here's my next point. I can draw my line, can't I? I can work out my line just by going 2 over 1, up 2, across 1, and starting at my x and my y-intercept. Okay, anyway, I've tried to rush it, go as fast as I can, but okay, so let's, hopefully you understand that getting a number pattern, you can plot it and then work out the difference there, and then go back to the 0 point to get the y-intercept value, and the 2 part comes from the difference between the numbers. And then you can plot that graph, 2n or 2x minus 1. The x minus 1 will be the y-intercept, so 1 dot, and the 2 by itself will be 2 over 1. So you go up 2 and across 1, and we can now plot this pattern of flames or this pattern of numbers by making a formula and then putting it on a graph. Whew, that was a long video. Hope you learned excellent stuff.